Hello, today we're going to be taking notes on 6.8 and a little bit of 6.9, Intro to Trig. Trig is just a short little abbreviation for trigonometry. You may hear me talk about trigonometric functions. Kind of some fun words. Today is 4/19/21, although if you're watching this in the future, I apologize in advance. All right, we define three important trigonometric ratios in right triangles. I asked you this weekend to get your calculators, so you could either have a TI-30, as long as it has the sine, cosine, tangent functions, and you want to make sure that this says DEG, that stands for degree mode. Or you have a TI-84, and you want to also, if here you would press mode, and you'll see a bunch of different things. Normal, float, radian, function, thick, sequential, real. Typically, we always just want to use everything on the left, but right now, and this is a key function, sometimes kids get like entire quizzes wrong because they're in the wrong mode. So right now, this calculator defaults to radian mode. You want it to be in degree mode. So you would scroll down to the right and hit degree. Okay, so to get back to the home screen on here, second quit. And now you're in degree mode. A really quick way, a sine of 30 is 1/2. Whereas if I was in radian mode, the sine of 30 would give me this ugly decimal. Okay, so you'll use that if you ever take trigonometry senior year or a little bit of pre-calc junior year. But so again, we want to be in degree mode in Math 2 today. And that's your quick check. Same over here. Sine of 30 is 0.5. Okay. So I'm going to put this one away now. I use this one. I'll try to kind of keep showing you here, but it's typically the same keystrokes. Sine, cosine, tangent, sine, cosine, tangent. And when you want to find an angle measure, I'll show you how to do it on here, but then I'll primarily use this. Okay, so we define three important trigonometric ratios in right triangles. Sine, so this is how you spell it the long way, S-I-N-E, but the abbreviation is just S-I-N with no E at the end. So all of these are three letters, but you still say sine, you don't say sin. Here, this is cosine of angle A, so again, don't say cos, please. Just say cosine, it's just an abbreviation. It's sort of like Mrs. Buck, right? You don't say MERS, okay? So you kind of say the whole thing. And any abbreviation. You still say the word, you just write the abbreviation. And then the third one is tangent, T-A-N. Okay, so if I were to go from angle A, and I've got three sides of this triangle, from this angle, this is the side opposite. Side opposite. It's just opposite the angle. Opposite is across. Okay, this is the right angle. So across from there is always the hypotenuse. Always, always, always. Across from the right angle is always the hypotenuse. Adjacent is maybe a new word. But adjacent means next to. A-D-G-J, rather, A-C-E-N-T. So from angle A, this is the side adjacent to, and you might be asking, well, why isn't it this side? Because this is the hypotenuse. It cannot be both. So from any angle, okay, let's say I went from B, okay, now everything would reverse. This would be the side opposite. This would be the side adjacent because this is still the hypotenuse. Okay. So the ratio, we just finished a bunch of weeks on ratio and proportion. So the sine of an angle is a ratio, a trigonometric ratio, of the side opposite divided by the hypotenuse. The cosine is the side adjacent divided by the hypotenuse, and the tangent is the side opposite divided by the adjacent. Okay, we will do this trick. Let me just do one, and then we can write down the little acronym. Okay, so from angle A, so the cosine of A. So the cosine of A is the side adjacent, which in this case is 12, over the hypotenuse. Well, I don't know the hypotenuse yet, but let's recall the Pythagorean theorem, which says a squared plus b squared equals c squared. And earlier in the year we talked about this, and we also talked about Pythagorean triples. So a couple of our triples are 3, 4, 5, 5, 12, 13, what's another one? 8, 15, 17. These are some really common triples. And then they're multiples. 9, 24, 25. I mean, there's an infinite number of triples. If you want to kind of think, you know, less than 100, there you go. Okay, so that means this is a 5, 12, 13 triple. So this is 13. So when I go to cosine is adjacent over hypotenuse, it's 12 over 13. And you're just going to leave it. You're not going to divide it and get a decimal. The sine of angle B, well, the sine of angle B, I'll circle B in blue here, is opposite side, which in this case is 12, over the hypotenuse is 13. Okay, so if you're looking here, the cosine of one angle is equal to the sine of its complement. These two are always complementary. Why are they complementary? Because if this is 90 and the sum of the angles in a triangle is 180, those have no choice but to be the sum of 90. So remember, these two are going to be complementary. They could be congruent, then you'd have an isosceles right triangle, but they're going to be complementary. Okay, and then let's find the tangent of B. I'll do this in green. So the tangent in B is the opposite side, which is 12, over the adjacent side, which is 5. So that's all you have. You're just going to leave it as a ratio of two things. So a trick for remembering the ratios is an acronym. An acronym is, you know, like the FBI or the CIA. They're letters that stand for things in real life. So Federal Bureau of Investigation, Central Intelligence Agency. Actually, SCUBA is an acronym. A lot of people don't know that. It stands for Self-Contained Underwater Breathing Apparatus. Kind of fun. All right, so an acronym is when you have letters that stand for the words to help you remember something. Okay, so the acronym that we used for trigonometric ratios is going to be SOHCAHTOA. Now, the key ingredient of any acronym is that it's accurate, right? Like, if you called this the FIB, then it'd be the Federal Investigative Bureau, and it wouldn't make much sense. You know, if you miss any letter in an acronym, it's not going to make sense. So the acronym is SOH. The sine is opposite over hypotenuse. So it's the first letter in each of these trigonometric ratios. The cosine is adjacent over hypotenuse, so CAH. And then the tangent is opposite over adjacent, TOA. So this is your new best friend in the whole wide world for the next 6 weeks. Okay? SOHCAHTOA. All right, so let's do a couple more. Find 3 trigonometric ratios for angle A and angle B. So the sine of A. So I typically circle it, it's kind of an old habit. You don't have to circle it, but it helps you realize that when I want to do the sine of angle A, I'm looking for the opposite over the hypotenuse. So the opposite side, let's reduce this. This is a 6, 8, 10 triangle, but let's reduce it to a 3, 4, 5. Then you don't have to reduce it every single time. So I'm going to reduce it to a 3, 4, 5, which I can do. I'm not saying that these are 3. I'm not just chop, because if I just chop this in half, it would be half the size. But what I'm saying is that the ratios then won't be different, because it's just a matter of reducing at the start rather than at the end. Okay, so the sine of A is opposite over hypotenuse, 3 over 5. The cosine of A is adjacent over hypotenuse. So it's just kind of another way to see that acronym. Maybe that'll help you. I just want you to understand that these are the sine, cosine, tangent, and then this is the opposite, adjacent, and tangent, or blah, opposite over adjacent. So the cosine of A is adjacent, remember I can't choose 5 because it's across from the right angle, over hypotenuse. And the tangent is opposite over, I'm going to make these equals because sometimes kids think then that they're negative. And they can be negative when you get to pre-calc and trigonometry because you're going to go march around the unit circle. But for our purposes here, we're going to just be in the first quadrant. Opposite over adjacent. So opposite over adjacent is 3 over 4. Okay. So from B, and if you want to pause the video here and try it, go ahead and do that. I'm going to keep rolling. So from B, if you're back from your pause, let's check these. Sine is opposite over hypotenuse, 4 over 5. Cosine is adjacent over hypotenuse, 3 over 5. And tangent is opposite over adjacent, 4 over 3. All right. Triangle ABC is an isosceles triangle marked as marked. Okay, so you're not going to remember this, but if I drop this altitude in an isosceles triangle, there's a little bit of a review. The median and altitude are the same thing. So remember, the median bisects it, so that's going to be 8 and 8. So remember, that's the midpoint. That's what a median does. It connects the vertex to the midpoint of the opposite side. Lots of vocab again that we've had before. And the altitude forms a right angle. So lo and behold, we have a right triangle. Okay? And the right triangle, and if you just remember Mrs. Buck's quick review of a Pythagorean triple, is 8, 15, 17. But let's say you're like, oh, I don't remember that, Mrs. Buck, so now you have to do the Pythagorean theorem. A squared plus b squared equals c squared. 8 squared plus something squared, oopsies, equals 17 squared. So 64 plus b squared equals, and if you don't remember your triples or your times tables, 289. I think I had you memorize only through 15, so that's where you might need to bust out your calculator. Okay, so now to bring this over, minus 64, and then you're going to take the square root, because remember, to undo that square is going to be the square root. So second square root of 225 is 15. So that's what we just found. So you can use what you've learned all year, Pythagorean triples, what's it called? Pythagorean theorem, that's what this is called, Pythagorean theorem. named after a wonderful mathematician of Pythagoras. I write a math paper on him. He's pretty interesting in college. And the triples. If you don't remember the triples, go ahead and plug and chug. And you have to have a calculator, not just your phone, because we're doing a lot more with degree on the next page. Okay, but let's answer the question. We didn't even answer the question. Look at all the things we had to know. So the sine of C, remember this is angle C here, is opposite over hypotenuse. So 15 over 17. Okay. Okay, this is where I'm going to stop. We're not going to do, on the other side here, on page 124 in this one, is kind of a little bit of theory and conjectures. So we're not going to do this. So if you're using a pencil, if you want to cross it off, you can. It's not that it's too hard. It's sort of, we're getting to the end of the year. That is just really important to kind of finish what we have to finish. So unfortunately, it's kind of a time crunch, which is also why we're hopping over 6.7. This is something called an identity, a Pythagorean identity. And again, we're not going to spend much time on it here. Maybe I'd ask you an extra credit question. But the SAT, ACT, you'll see this Pythagorean identity, which leads to this one. If you subtract sine squared, excuse me, and then which leads to other things. But again, we are not going to spend, time on that just because of time. I don't want you to think like, oh, we skipped it, it's too hard. No, it's not hard at all. It's just, that's another day or two that at this point in the school year is becoming a little bit precious. But this is something that you should note, that it's not challenging. It's the most famous, what they call Pythagorean identity. Okay, so that ends us here, and then for part of our homework, part 1 is 6.8. This is page 125, so you're literally just doing a couple of these, do you know the sine, cosine, tangent relationships. On the other side was more examples, feel free, and here find each of your values. Okay, this is worth, and this is kind of why it's notes here. So I just want to make sure you know how to find this on your calculator. So make sure you are in degree mode. I already identified that. And round to the nearest 1,000. That's 3 decimal places. So let's do that. So the sine of 21, take out your calculator. Clear up anything you want to by hitting second quit. That will clear. Get you back to the home screen. So you're literally, since we're already in degree mode, going to hit sine of 21. All right, so 3 decimal places is 0.358. Now I'm putting a squiggle because this is not exact. The ratio, you would leave it exact. Approximation is a squiggle. Cosine of 20 is 0.9396. Now, I am just going to let you truncate that because on Canvas, it's just going to be too messy. Technically, if you're looking at 3 decimal places, you should round, and if that's a 6, that's going to bump that up to a 10. So then you'd have about 9.940. But that's a whole other lesson that I know that a lot of you have kind of forgotten some of your basics with a year off school. And rounding is maybe one of them that's not that important for me. Oh boy, we got to change our password today. Get it in there. And I'm just going to kind of let you truncate. This is called truncate when you just leave it. Truncate is if, so on Canvas I would have to accept 0.939, or I would have to accept 0.940, which is rounded. So this is truncated, this would be rounded. And don't, it's not hard. I know it's just been a while. Like 6 would make this 9 a 10. So 39, bumped up 1 is that 40. Okay. Okay. Tan of 17 Whoopsies. Now you might be wondering why I'm not closing it. I could absolutely close it, and I really should show you that. Now here, I am going to round this because that's a little bit easier. 305 would be a truncate. 306 would be rounded. So it did say to round. I just, you know, if you got that wrong on a Canvas quiz, I wouldn't want you to. I'd want you to be able to, you know, get that right. But if you really should practice rounding, because again, back to like an ACT, SAT. Tangent of 22, you want to have the right one. Here's what I usually do. I just cheat by going around that issue. If I'm testing that you know how to do this on your calculator, I'm probably going to pick one that doesn't have to be rounded. So that's sort of my workaround sometimes. Sine of 77 is 0.974. And the cosine of 87 is 0.052. Yeah, 0.052. Okay, those are some great examples on the calculator. All right, now, really quick, we are going to, I'm going to hop over the review from yesterday. This might be my opener tomorrow. We're going to talk about to find the missing sides of a triangle. So now I'm on page 127. Page 127. It's a notes that I'm kind of mushing together two quick things today. All right, so to find the missing sides of a right triangle. So if you want to find x, so this is the x value, okay? Given the measure of angle A and the adjacent segment, okay? So the measure of angle A, where is this? Yeah. And the adjacent segment. Okay, so this is the side opposite that I don't know, and I know the adjacent. Okay? So that means the sine of 42 is equal to x over 12. The sine of 42 is equal to x over 12. So we just are still in this unit 6 with the proportions. I'm going to get this x by itself. Well, how do I do that? I'm going to multiply both sides by 12. So on my calculator, I'm going to hit, let me clear up shop there, 12 times the sine of 42. So that is going to give me x is approximately equal to, let's round to the nearest tenth. So this is, or hundredth, we'll go hundredth, 8.03. So nearest hundredth is 2 places. Okay. So we just found x, and then to find y, I'm going to say, okay, so the cosine of 42 is equal to adjacent over hypotenuse. And because we are rock stars, we're going to cross multiply. So y times the cosine of 42 is equal to 12. And I'm going to get y by itself by dividing by cosine of 42. Now sometimes kids are like, well, wait, why do we divide there and multiply there? Because here are the variables in the numerator, here are the variables in the denominator. Okay? So on your calculator for this one, and here it is here. I didn't see that because my calculator was covering it, so perfect. Nearest hundredth is 2 places. I'm going to hit 12 divided by the cosine of 42. And you might want to get in the habit of closing your parentheses. So y is approximately equal to 16.15. So after that 4 is a 7. After that 4 is a 7. So rounding is you look, to the right. You've got all kinds of things from junior high, like, more than 5. No, wait, 5 or more, raise the score. Less than 5, take a dive. Something like that. So, then you're looking at missing angles. I might have to stop here. This is kind of a lot. So, we're going to stop there. Tomorrow I'm going to talk about missing angles. That'll be in the next video. And so on this page, you're still just going to do page 129, and you are good there. We don't have to find the angles till the other side. All right, so I'm going to stop there today. You just have pages 25 and 29, and that's on Canvas, and that upload will be ready soon. Watch this video again, pause it again if you need to, speed it up if you want to. I'll give it to you as YouTube so you can just so you can fast forward at your leisure. All right, see you soon.